Green light. Green light. All right, cool. Here we go. Yeah? What do you mean? How did I do what?
He's the one who said that. I said you shouldn't be calling me. Yeah, he said, he was saying that like he don't like it.
But we're testing tomorrow.
I know, right? She got defensive, but
What I can do is I can lend you one. Practice tonight. That good? Come here.
so how much you guys need to buy?
I'll sell your house.
Okay. So, waterfalls. Here we go. Wait. Sorry. Who's?
Oh, there's a super cute.
We're good now? No, oh, you're still right. Okay. So we're gonna have to go through this really slowly. This is trippiness. This is one of the crazy sections. No, we can't skip it because yeah, you're still gonna have to do it. That's not what I wanted to do. I just have that. Okay. All right, here we go. Waterfalls. So, partial fraction decomposition is the name of the game. Partial fraction decomposition of a rational expression with distinct linear factors in the denominator. Distinct linear factors in the denominator. So, the partial fraction decomposition has distinct linear factors. The form of the partial decomposition of a rational expression with distinct linear factors in the denominator looks like this. So here is what you're going to be breaking down the things down into. Go ahead and write that down. This is just your generic form. Yes. Pobrecito. You could do partial fraction decomposition as PFD. Just, what do you call it? Condense it? Call it PFD. I hope people are catching this on YouTube. Go back and watch this. I look scary because it is. So please get it down. And we'll just go as far as we can. Yeah, then there's just the pattern. So it'll be the first binomial, the second binomial, third binomial, and these are just linear factors. Hopefully, right now, right? Linear factors. So it should just be like an x plus 2, an x plus 3, x minus 4 type thing. And we're talking about the first binomial, second binomial, third binomial, and so forth until the most number of binomials that you have. Yes? That just means that's the biggest one that you have. So if you were to continue the pattern, 1, 2, 3, 4, 5, n is simply how high it goes. Okay? Thank you for asking. Please ask your questions. No time to be shy today. What? Did she fart? Is that what you scooted over? We've had it with you, Malia. That's it. How can we mad at Malia? She's like the sweetest person that I know. Okay.
I'm so glad I wasn't here.
Are we looking at this? Why are you looking down there?
You're looking at me.
That's inappropriate. Wait till you get home. You guys ready? For the scariness?
No!
No, you're not ready for the scariness.
Scariness.
That's probably the.
Give me a few
Thank you.
seconds to like mentally prepare myself.
It just looks scary because it means nothing to us. It really doesn't. A lot of things in math have to be put in a form that is pretty universal so that we give it to another mathematician. They should be able to hopefully decipher it. So let me explain to you what this means in English. Sounds good? So let's go on to here. Now we'll come back to these steps, but let me explain to you what this means in English. Do you guys see my fraction up there? Or my rational expression, if you will? Notice that there's two linear factors at the bottom, right? Two linear factors at the bottom. That means that this problem came from adding two other rational exponents, right? Or sorry, two more rational expressions, where one denominator maybe had x minus 3, and the other fraction maybe had a denominator of x plus 4. Does that make sense? So this had to come from something that there was two fractions, one had a denominator of this, one had a denominator of that, or maybe one had a denominator of this and one had a denominator of both of them. We don't know, right? So partial fraction decomposition is saying, hey, what could have been the original fractions that this came from?
I like it.
What? You said fraction and you lost me.
So it's like they
Ooh, you said the F word. What?
So like they give us the answer and we have to find.
Yeah, the problem.
Yeah.
So yeah, that's a great way to think about it. Thanks, Silly. So you have the answer. You have the sum of would have been some fractions. The question is, what were those fractions? Everyone understand the concept today? Give me a thumbs up if you understand what I mean. Sideways if you're a little confused, down if you're not. Okay, so, Clay, let's think about this real quick, okay? If I took a third and a quarter, what would that end up being?
12.
Well, my denominator would have to be a 12, right? And then this would have to be 4 plus 3 kind of thing. So this is 7 twelfths, right? So this is equivalent to that. And we're trying to figure out what it came from. Does that help?
That makes so much more sense.
That's all we're really doing. Now, truly, this 12, what did it come from? It came from 3 times 4. Do you see the two numbers there? And then you see the sum or difference of two things there?
So the original one would be like 5x over x minus 3 minus x.
Could have been. Could have been. Do we know what they are? No. Do you see the problem here? So that's our job today. Yes.
So does that mean there's only one way, or is there like?
Technically, there's always only one way.
But I feel like if they're like.
You won't have multiple solutions, no. There'll be one that best fits. Okay? So, let me see those thumbs up, thumbs down. I understand what we're doing. It might not be nice, but I understand what we're doing. Okay, which part confuses you still? Because you need to know. Because if we don't know where we're going with this, I didn't see the thumbs on this side, sorry. Are we good? You got a question? I can't hear you because there's some conversations over here. So how does it correspond? Fantastic. So let me go back to that. So what we're going to do is we're going to take the denominator, see how it's all those binomial factors, and we're going to make them individuals.
Oh, so let's say we're showing.
Yeah, so this would be like the answer, and what we're going to, our first step will be by breaking it down into fractions, where we know that these had to be denominators, right? See that? Here's my a plus 3, there's that. Now do I know what's supposed to go on top? No, that's why they're a sub 1, a sub 2, a sub 3. And then that will be figured out later on, because this is simply a function, and we'll have to split them up into those values. So let me give you a more concrete, okay? If I have that, if I have that 5x minus 1 over x minus 3 times x plus 4, then that means that it had to come maybe from some fractions, that had, we'll call this a sub 1 because I don't know what's supposed to be up there. But it could have had a denominator of x minus 3. And then the other one had a denominator of x plus 4, and I don't know what goes there. Does that make sense?
Why don't we?
That's what we're doing. That's what I gave you at the beginning is. We're going from this, and we're breaking it up into pieces or partial fractions, with those denominators being at the bottom. So technically, this would be the a sub 1x plus a sub 1, while this is a sub 2x plus b sub 2.
So is that why you make the every expression like 1 over
Right. And do we know what goes up top? Can I just look at this and know, oh, the 5x goes here and the minus 1 goes there? No. Because remember, there's changes that go on, right? In order for the denominator to change, I have to change the numerator type business. So that's kind of what we're talking about with that formula. Okay? The what?
No, that was an example.
Waterfalls. Guys, expectations is that now that we're doing this lesson, you guys are actively listening. Because these might be questions that come up again, and that's what bugs me. I think I told you guys, right? When people ask me again, and I just said it, but you didn't hear it because you weren't listening. Go ahead. I want to make sure that you understand it.
I get this part, but I don't know where what are we talking about 1/3 and 1/4 thing?
The 1/3 and the 1/4 thing. No, that was the explanation for him, because he asked me like, I don't understand what I'm doing here, and I said, here's what we're really doing. We're taking some fraction, like 7/12, and we're breaking it up into the two original fractions. Okay. Now 7/12 really came from a denominator that was 3 times 4, wasn't it? So what had to happen was we had a fraction with a 3 and we had a fraction with a 4 in it in the bottom. That whole idea. Go ahead.
But it could be different too, right?
Well, not really.
Because it's 6 and 2. 12 and 1.
Yeah, but if it was 6 and 2, then my denominator would be 6 because 2 is a factor of 6, isn't it? Ah, fantastic question though. You made me think about it for a second.
Why can't it be 6 and 2?
He said, well, you know what? The 12 can also be broken up into 6 and 2, can't it? But if my denominators were 6 and 2, then my denominator over here should have been 6 because 2 is a factor of 6.
Oh, and you would simplify.
Right.
Oh.
Are you having problems with the...
Why am I having such a hard time with this? I don't understand.
I don't know. Well, people are asking questions. Like how do you know that it's only going to be one solution, right? Because there's only one way to actually do it. If there was a different denominator, then that's because there was different factors at the bottom. Okay? So I like that you're doing that and you're thinking about it. But if that was true, then we would have a very different denominator over there. Okay? Yes? Oh, snap! Ah, and I can't undo. Can I undo? If I do Control Z, I don't think it's going to. It's a different thing altogether. Yeah, I won't do it. What part did you want?
Well, I get the denominator, but I still get
Waterfalls. Thank you.
I get the denominator part, but how do you do the numerator? If it's
That's the objective. That's the hard part. Like right now, all I did was answer questions. Where did the formula come from? Well, that's how we set up what we're about to do. And then we're going to have to figure out what the numerators are.
Are you going to solve that one?
Nah, of course I am. Are we good so far? Are there any other questions still? Did we answer yours?
So the correct answer for that is A sub 1 over...
No, we haven't finished it. Here, look. Here's what we're, let me go on real quick here. So, here's my setup. That's what I wrote, correct? I don't know what A and B are yet.
Wait, B plus B is 2.
B gives A sub 2. And you can do A, B, C. It's just variables. Okay? So here's the equation part or equivalent of what you wrote down at the beginning. We're taking that problem and we're breaking it up into these partial fractions. Simple enough? Okay. Any other questions right now? Any other questions? I want to make sure we're good at this point. That makes sense. I know why I have to do this. Give me thumbs up, thumbs down.
Oh. I was like,
Okay. Who has a question? Go.
Wait, so wouldn't you have to multiply like the top number also by like the 4x?
yeah, that's what I was thinking.
Yeah, but that's what we're.
Say that again.
You would have to multiply the top number by the x.
Right. So I'm telling you that you're right. This would change somehow. These aren't the original numbers because whatever was there, this would have to go 4 times x plus 4. Whatever number was there would have to go times x minus 3. Does that make sense? Cool. So yeah, you're right. But we don't know what numbers they came from. What was there originally? That's where we're headed to. That's where we're going. What's up?
So the A and the B in the numerator.
A and B,
That's the same thing as A sub 1.
yes, and A sub 2. They're just placeholders. Okay? So right now, what we're after are A and B. Simple enough? Obviously, these would have to be my denominators. We're trying to find the numerators now. Yes, Lord.
Is it always going to give it to us like that?
You'll always get this. And you'll have to break it down. Lisbeth? Ready? First step. We're going to multiply both sides by this denominator. The x minus 3, x plus 4. Because that's going to make it, what's the magic word? Yeah, and I'm throwing air quotes up there for the recording. It's going to make it cancel out. So this is going to go away. And I'm going to get simply this numerator by itself there, which is 5x minus 1.
oh, yeah.
Right?
What is that?
Wait, 1 second.
Oh, look, okay.
So then aren't you gonna multiply the top, the A and B plus?
We have to multiply this as well, correct?
And parentheses, right? So we have to multiply.
So we're going to have to multiply this out, correct?
By this one.
Yeah, because we don't want this denominator. We want to get rid of it because we want a model that we can follow.
So what happened on that side, it's going to happen to that side.
Not necessarily, but some of them might go out. Not all of them. Because if I distribute to, when I distribute this thing to here, the x minus 3's will cancel, but we'll get A times x plus 4, won't we? And then when we distribute to there, the 4's will cancel, and we're going to get B times the x minus 3. Right? Let me get rid of this. I don't want to keep the writing here because it'll save it. And then I have to be fighting it next year. So we're good with that first step. We're converting this fraction to just be some type of linear, well, non-rational expression. So here's what we get. Yeah? I think I just showed that a second ago, correct? We're good? Nothing fancy yet? I can wait if you need me to. I was hoping we can just kind of flow through this and then right at the end, but it's not. No, it's not because it's not a smart thing. It's not a smart. Yes. Why does what? Okay, so if I were to distribute these two to the first term, right? I would end up with A times x minus 3 over x plus 4, correct? And then the bottom I would have x minus 3. Well, what happens with my x minus 3s? They make a 1. So we were just kind of erasing some of that, getting rid of some of that extra work there.
So you're going to multiply it by the opposite.
No, it's not the opposite of denominator, it's just the denominator. Yeah. Okay. Are we good so far? We're still good? Okay. Ready for the next step? We're going to clean up this right side. We're going to clean up this right side. So we're going to get ax plus 4a plus bx minus 3. Right? All this is distributing the a. ax, 4a, over here it's bx, and then minus 3b. Are we okay so far? Cool beans. Here's where the math magic comes in. Because right now we haven't really done anything that's really that difficult, right? We're going to throw in some math magic now. 5x minus 1. I'm going to group these guys. I'm going to group the ax. I'm going to kind of put them together like this. And then I'm going to group the other two. So that's going to give me, yeah, technically, huh? Is that what I wanted to do? 4a. Is that what I wanted to do? Give me a second. Yeah. All right, we're good? Yes, that's what I want to do. Are we good? All I did was group the x's together and whatever didn't have an x together. Right? We're good? Okay. Here's my next move. 5x minus 1 is equal to a plus b
Oh, and so you took out
x
that.
plus 4a minus 3b. Okay? Please process that first. Go ahead, Lily.
Does it matter if the X is in the front?
It doesn't, but I like it there because I'm going to tell you exactly why right now.
I put the X in it. I put the X in the front.
I hate that you put it in that.
Yeah.
I think he put it there for a reason.
I did put it there for a reason, and I'm going to tell you why right now. I want to make sure you understand what I've done so far. You were mad at her. How are you eating her brownies? Is that how she made up? Okay. You guys are so smart.
Hey, play for the Brownies.
They were
Did
brownies?
it get approved by
Yeah.
the FDA? Could be in J for chocolate.
I actually have food handles card. A food handles card. I have one. Yeah.
Okay. Any questions at this point?
Oh, wait.
Thank you. Sure. I just do things. I don't like really think about each step.
Just hanging out so I can start more organized and
Well, let me take that back. Michaela and K-Rod don't switch flat. This is what I do.
Let's go half these.
Did you really eat two
What, did first hour get done until we did?
I did not bring donuts. Michaela and K-Rod donuts.
Hey.
Thank you. So, looks like we're done. No, looks like you're done writing. Sorry. We're not talking about waterfalls. So I have this and I wrote it this way for a reason. What does this symbol mean? What does it mean? That this side is equivalent to that side, right? How many terms are here? How many terms are here now? 2. So, here's what I know. Notice, this is x, isn't it? This is x. So that means that a plus b equals how much? 5. And that 4a minus 3b equals how much? -1.
Oh my God!
Wait.
Wait.
a system where I can solve for A and B, and then I throw them on the top of the numerator, and there's my fraction decomposition.
So A.
Man, applause.
Oh, think it's important. I'm just gonna buy you sheets of highlighted paper. It's a joke.
Entire time.
What's
Cut that. Oh.
It's a good look.
Wait, Shereen done?
No, with the
Now you have to solve the system, and then get your. You want me to go ahead and do that?
Yeah.
Okay. I'll wait for a few to write this down.
What is your favorite donut?
like downtown San Diego, and they made like they had like Homer donuts in them. It's like these huge donuts, and they had like this little blue one. That was so good. It was so good.
Does the nurse have allergy pills?
I don't know. Maybe. She might. I think she has the red one. It's Benadryl. Yeah, they do. Waterfalls. I'm gonna get rid of this. So let's go. So here's our system. Once we solve it, we're going to see that B is equal to 3 and that A is equal to 2.
Good job.
Oh, and we use the substitution.
We did elimination here,
Elimination, yeah.
and then we substituted over there.
What's the system of equations?
What did you say?
Oh, I didn't do it like
That is what makes teaching math
I did it.
the best.
I didn't do
That
it.
makes
But I saw it there.
But people
So I
go,
know.
I did not see that one coming. Plot twist.
Wait, Miss. Why is the jealous? That's not a negative one. No,
yeah, but they swapped the signs, right?
yeah.
So this was it was a negative 4A.
Okay, so they multiply the top by negative 4 so that the A's cancel out, right? So then they add the B's, they got negative 7B equals negative 21, divided by 3, you got B equals 3, plug 3 back in, they cancel 5. It's a system.
This is just literally what we did.
Yes, but with A and B instead of X and Y.
No, that's my favorite.
I should.
Yes.
Look at
Waterfalls. You need to handle your dealings in silence. They were all switched values. Can we go back this way? What did I do?
You lost our values.
Oh, this is supposed to be a -1.
That was you messed it up.
There's literally no one next to me.
Does that hold on? Does that change anything?
Yeah, no, it changed. Mr. Munoz, look on the second one.
Oh, they put it back in. It's just a typo here. Let me fix it. And show. Oh, come on! Don't be dumb. It's not gonna let me. But it's just a typo. This one should be a -1. What's it saying? The server application source file cannot be opened. Whatever. All right. fixed it. Is that overtime? Well, it didn't take long. It took long because I was explaining everything. When you're doing it, you're going to be working in your time, so it's going to be a little bit faster. Now, I'm not going to say they're going to be fast problems to do, but it just took a long time because I was answering questions and doing all that stuff. Okay. Exactly. What long? Oh, thank you. Guys, on the review, please don't do 100 and some questions. Focus on
3.5. The ones you need help on.
Focus on what you're struggling with. If you already know how to do something, don't waste your time with it. And yeah, you know what? Waterfalls, 30 is a good number. So if you want to do about 30 of them, but you feel you need more, okay. But remember, it just comes down to review. You are reviewing. No. Because the review is meant for you to get better, right? So if you feel that you need all 100, more power to you. I've seen people do that. Last year, not saying no names, Cammy. So do what you need to do on that, okay? Just review, make sure that you're good and ready. All right? Now, are we done with this? How are we on time? Oh, I have time.
It's like,
9:50. No. 8:45. Oh, I got 15 minutes. So, 8:45. 9:35. Oh, then we don't have enough time. So tomorrow, go ahead.
So the answer to this would be 2 over x minus 3.
Absolutely. Isn't that cool? All right. So in my
Oh
my gosh.
Wait, what? Oh, okay.
isn't that cool?
Now, can you solve that? Just so I can see like the way it works again.
There's no solving here, sir.
No, like can you solve?
And x plus 4. This is going to become 2 times x plus 4. This will become 3 times x minus 3, right?
How you check your work.
You can. So now we have 2x plus 8, and 3x minus 9. So 3x minus 9. This is 5x, and negative 9 plus 8 is negative 1.
So that's just one scenario, right?
That's the only scenario that will work for this. Yes. Waterfalls. There is no fumbling around with the math. Remember, when you have a system of equations, how many solutions can you have? If it's 2 linears, there can only be one. Therefore, there is no saying, that's one way you can get this. That is the only way you can get this. Okay? So.
Wait, is this going to be on the test tomorrow?
No. This is chapter 7. Your test will be chapter 3. Okay.
What if you just pulled the sneaky one in?
Waterfalls.
Yeah.
I want to take just a little bit to set up for tomorrow. This is going to be, now this is a different type of problem. And this type of problem is when we have repeated linear factors. That means that we have something that's to the nth power. So like a second power, third degree, fourth degree, so forth, so forth, so forth. The idea being that maybe you had something like where your denominator is 3 squared. Okay? So technically this is 1 over 3 times 3, right? So this is kind of goes back to kind of what Corbin was talking about a second ago. Corbin, stay with us, please. So we could have a fraction where my denominator was a 3 and my denominator was a 9, right? And because 3 is a factor of 9, then I would only need that 3 squared, which is 9. So it's that idea. Okay?
So how do you know which one's the what?
So that's what we're going to do from here. That's what we're going to do from here. Now, go ahead. Hold on. Clay.
All these methods have like a different way of solving each one, or is it pretty standard?
It's you just kind of, in the way that I see it, because I see how they would work now, it seems pretty standard. You just have to think about what has to happen, but as you're learning it, you're going to feel like it's a different scenario. So if I think about this, maybe I did have, I don't know, some fraction. I'll just go 3x plus 2, and that's over x minus 5 squared. Okay? What are the scenarios I could have had over here? What scenarios could I have had? My denominator could have been
X minus 5.
x minus 5,
And then X plus 5.
or it could have been, no, not, where's plus 5?
Oh, well, I'm doing
Or it could have been x minus 5 squared, because this is a factor of that, it doesn't need to show up, right? Are there any other scenarios?
X minus 5 and X minus 5.
There aren't other scenarios. So, I just did those just because. So this would be my breakdown, and this is what you have here, see? First degree, second degree. If this was a third, then I would have, oh, it could have been a first degree, a second degree. I had a third degree with a 1 degree, because that's a factor. But I want to make sure I account for all possible scenarios. And so it's still the same idea as the last one. Okay? All right, so I'm done for today because there's no time. Please make sure you do that exit ticket.
Wait, are we testing tomorrow or are we going over this?
We're testing tomorrow. Yes?
What was step 6 for the first one?
Okay, hold on. Waterfalls. The best that I can do for you is push the test to Friday, but we continue with this one tomorrow. So do you want to test tomorrow or do you want to test Friday? Show of hands. Friday. We'll talk to you guys later. Have a good one. You better be here too. People are like Friday, but they don't know I'm going to be gone for the weekend.
We have a lesson next Tuesday. That is the official New Year's Giving. On New Year's Giving,
How come you skillingly decided
Wait, that's called
It's still recording.
actually safety thing?